Hello Chemistry, this is the video that goes along with Lab 27, EXO or Endo. We're going to take a look at three different reactions. First off, we're going to dissolve calcium chloride into water. Then we're going to dissolve ammonium nitrate into water. And then we're going to mix sodium hydroxide, which is a base, and hydrochloric acid, which is an acid, obviously. Right? And we're going to monitor the temperature change of these reactions. Before we do that, though, it's important to recognize two terms that are very important when discussing endo or exothermic, and they are system versus surroundings, okay? So you can't see the system here because the system is each set of individual molecules. They're too small to see. So what we measure today will be the water, which doesn't participate in the reaction, and so it is the surroundings. So if we see the temperature go up on our temperature probe here, we'll say that the surroundings are gaining heat, right? And if we see the temperature go down on our probe, well, we'll be saying that the surroundings are losing heat. And then we have to infer what the molecules are doing based off of what the surroundings do, right? So if the surroundings gain, then that means the molecules, the system, must lose, right? So on and so forth. So if you have questions about that, you can, of course, let me know. But it's pretty easy, right, to determine which one is exo and which one is endo. Exo gets hot. Endo gets cold, right? But you got to think about that in terms of system versus surroundings. All right, before we begin here, make sure you write down 24 degrees Celsius as the beginning temperature for each of these reactants here, or each of these systems, or sorry, each of these surroundings, right? Because it's water, and this is solutions here. Right, so mark down 24 degrees Celsius as our beginning temperature for each of these reactions. Right, and then all you need to do is mark down the final temperature. The first reaction we're going to do is we are going to dissolve 1 gram in 20 milliliters of water. This is 1 gram of calcium chloride. Let's take a look at that temperature and see what it does. Alright, there we go. It's pretty much dissolved now at this point. We went from about 24 degrees initial to about 28.5 degrees for the final temperature. And if we touch this beaker here, hold it in our hand, feel it feels a little bit warm. Okay? So the temperature there went up. Alright, let's think about what that means as far as exo or endothermic. All right, we put it back into our beaker over here. It's going to come back down to about 24 degrees, which is about room temperature in here right now. Next, we're going to do ammonium nitrate. Okay, so we're going to put our thermometer into our 20 milliliters of water. So we're monitoring the temperature. Okay, we're monitoring the temperature here. We're going to go ahead and put our ammonium nitrate into the beaker. Watch what the temperature does. Here, hopefully, it seems pretty obvious that the temperature is most definitely going down. All right? Went from a very high temperature in the first case to this reaction now, the temperature has decreased a couple of degrees. All right, so let's think about what that means in terms of exo or endothermic reaction. All right, about 19.2 degrees is the final temperature there. And if we touch this beaker, it feels a little cool to the touch. All right, let's think about what that means in terms of exo or endothermic reaction. Okay, for the last reaction here, we've got a mixture of sodium hydroxide and hydrochloric acid. So this is different from the other two, which were solution reactions. This one is going to be a neutralization reaction, right? But we're going to use the same initial temperature here for hydroxide. I'm measuring the temperature of the hydroxide, but you can Make sure you write that down for both. It's 24 degrees Celsius. All right, now we're going to add our acid and watch what happens to the temperature. All right. Hopefully you guys see that giant jump in temperature there as we went from the basic solution and we neutralized, right? So let's think about what that means. It looks like we got up to a maximum temperature of about 58.5, something like that. So make sure you write that down. If we touch the beaker here, it feels quite warm. It's almost too hot to hold, actually. All right? Okay, so there were our 3 reactions, exo or endothermic. Go ahead and answer the analysis questions. Make sure you're putting this into your lab notebook.